and welcome to my post on magnetic monopoles. According to Dirac, magnetic monopoles would look like negative energy particles, and space should be full of them. But it is hard to see something that surrounds you. You only see evidence of them when space moves or cracks, as when in a lightning strike, an earthquake of space that sends out light and thunder as S and P waves. But what is negative energy in terms of flow? Is this exergy just a flow in the opposite direction? An electron is defined by a current flowing in the clockwise direction, and a positron is defined by a current flowing in the counterclockwise direction. So if you turn around and face the opposite direction, everything you previously called a positron becomes an electron, and vice versa. Is a magnetic monopole therefore the same thing as a positron? Is the difference between electrons and positrons the same thing as the difference between spin-up electrons and spin-down electrons? Wouldn't that be something? You can create something that looks just like a magnetic monopole by taking a magnetic dipole and stretching it out so that the ends are really far apart as you want, really. Conversely and contrariwise, we might say that there is no such thing as a true electric monopole, because every electric monopole is connected to its oppositely charged self via a long entangled string, stemming from the moment that the particle pair was born. A physicist might object, we can isolate electric monopoles, but we cannot isolate magnetic monopoles. But what if the difference between electric monopoles and magnetic monopoles is really the same thing as the difference between electrons and positrons, the difference between matter and antimatter, the difference between two electrons going in opposite directions in space, the difference between two electrons going in opposite directions in time, the difference between a spin-up electron and a spin-down electron, the difference between a positive hole and a negative hole in a semiconductor, the difference between an up qubit and a down qubit in a quantum computer, the difference between an electron with weak isospin and an electron without weak isospin, the difference between a positive energy particle and a negative energy particle in a Dirac sea, the difference between a clockwise swirl of charge and a counterclockwise swirl of charge. So many ways to say the same thing. Swirl of charge, swirl of space, swirl of time. What is the difference? Depending on your perspective, there really isn't one. The reason that nobody explains things this way is not because the math is too hard to do if magnetic monopoles exist. In fact, magnetic monopoles are used to clarify and simplify complex theories in the Standard Model. But this is sort of like digging a very deep hole of complexity, climbing back out of it and calling that progress. In general, you can dramatically simplify Maxwell's equations from the start if you believe in magnetic monopoles. The form of Maxwell's equations that everyone knows is only invariant under Lorentz transformations, but it is possible to write an equally valid form of Maxwell's equations that is invariant under Galilean transformations. You just need to assume magnetic monopoles exist and get rid of magnetic and electric displacement currents. It isn't controversial to suggest that magnetic monopoles exist in an abstract sense, and it isn't controversial to get rid of the displacement current in a non-relativistic approximation, in which the speed of light varies while space is constant, as in a Galilean system or absolute reference frame. But if you need to explain how a capacitor works without the concept of displacement current, then you need magnetic monopoles tunneling through space, just like electric charges tunnel through solids. And the electric charge, E, times the magnetic charge, Q, is equal to 2 pi. You can even do quantum mechanics with the Galilean Maxwell's equations. It just isn't terribly popular because certain situations are more convenient to describe with the Lorentzian Maxwell's equations. But if magnetic monopoles exist in Galilean Maxwell's equations, then Gauss's law has to be modified, and we have to take a second look at Coulomb's law, since it is derived from Gauss's law. Gauss's law is that the quantity of sources within a surface is proportional to the stuff flowing through the surface. For example, you can measure the output of a water spigot by putting a balloon around it and measuring its expansion. It's a conservation law. Gauss's law would be wrong if the system is not conserving energy. For example, if I squeeze a balloon or lower the pressure outside of a balloon, the system is no longer conserving energy. Empty space exerts a pressure on charges, and some people believe that either empty space is literally expanding over cosmic distances, or empty space is vibrating, giving the illusion of expansion. In either case, energy isn't conserved, and that suggests that you need to take a second look at Maxwell's equations. Which type you're using. The area surrounding the source absorbs energy from the source ever so slightly faster than the source produces it. The pressure of the surrounding area feeds energy back into the source, keeping it in motion, but over time, less and less of that energy makes it back into the source. But physicists do not tend to speculate about such matters because none of this would be relevant over the timescales on which we can conduct experiments. Maybe this is overcomplicating things by worrying about Gauss's law. Coulomb's law is a static approximation of a much more dynamic reality. And if magnetic monopoles don't exist in a static picture, but they do exist in a dynamic picture, then we don't have to throw all of electrostatics in the trash. That would be nice. In the meantime, electrodynamics becomes much simpler if we use magnetic monopoles and Galilean relativity instead of displacement currents and Einsteinian Lorentzian relativity. Because instead of describing an electron in a magnetic field with covariant velocity and a Wigner rotation, you just use the regular velocity and the rotation isn't needed. I think the evidence for this can be found in a mess of a debate between two high-ranking physicists that I found. You can see the link in the blog post I wrote on this. I believe that this story could be nicely tied up with a theory from the 1800s called gravito-electromagnetism via a derivation described along the lines I've linked to in my blog post. When I try to understand how science develops in a historical sense, I wonder if you had a discipline which selected people based on motivation to swallow and regurgitate complicated ideas rather than based on the desire to think things through on a fundamental level, you might end up with a rather stupidly overcomplicated, convoluted discipline with overlapping definitions of things that could be defined more simply, because it is far easier to trick such people than it is to convince them that they have been tricked. Wouldn't it be awful to find out that all of physics' mysteries resulted from stupid mistakes of omission and sloppy definitions? Good liars tell lies that are mostly truth. Outstanding liars can lie without uttering a single falsehood. An outstanding lie is a lie of negative space. It lies in the margins of truth. The lie is a lie of misdirection. It brings the victim to the wrong conclusion by what it leaves out, not by what it includes. Another common tactic is repetition. Keep repeating the lie over and over and over again, and people will hear it so often that they'll accept it as true. I find it instructive to compare this perspective to a typical nonsense popular science article on the topic of magnetic monopoles. The enduring mystery of detecting the universe's only magnetic monopole. I wish bad science communicators would just quit. It is also instructive to connect the magnetic monopole concept to gravity. If you think of positive and negative masses, you have chosen to think of mass in the same way that we think of charge. If you want to do this, go for it. It is completely legitimate if you are consistent. But no one else treats mass like this outside of the subspecialty of Bose-Einstein condensates. So you will look weird, and people will treat you accordingly. Due to whatever accidents of history, we treat electromagnetism with positive and negative charge, while saying that magnetic monopoles don't exist. At the same time, we treat gravity with monopolar mass and say that positive and negative masses don't exist. I think that you could rewrite atomic electromagnetism in the language of magnetic monopoles, and it would end up looking exactly like our conventional descriptions of gravity. I also think that you could rewrite the language of gravity in the language of positive and negative masses, and it would end up looking exactly like quantum mechanics. The reason that no one ever does this is that experimentally, quantum transitions in a planetary system would occur over timescales that are far too long for people to measure, and gravitational descriptions of atomic systems make predictions that are far too fine for people to measure, because they happen on timescales that are far too short for us to access. Despite this, thinking in both ways, on both sides of the mirror, gives a lot of meta-insight into the structure of the fundamental forces. As long as you don't mix up the languages or geometries, it is okay to try something new. Conventional descriptions of atoms say that the nucleus attracts the electron due to intrinsic opposing properties of the proton and the electron. The proton has a positive electric charge, and the electron has a negative electric charge. We say that they don't crash into one another because of the Pauli exclusion principle, or zero-point energy, or whatever you want to call it. In contrast, we say that the sun attracts the earth, and the earth attracts the sun due to the intrinsic property of mass. The earth revolves around the sun because they are in relative motion. Reversing the descriptions, the sun attracts the earth due to intrinsic properties of the sun and earth. The sun has a positive gravitational charge, and the earth has a negative gravitational charge. They don't crash into one another because of some planetary principle. With a quantum analog. Meanwhile, the proton in the nucleus attracts the electron due to a single intrinsic property which they both share. They don't crash into one another because they are in relative motion. Notice how removing a single word from the lexicon, magnetic monopole, exergy, or negative mass, makes the explanation of these concepts exponentially more complicated. I wonder if that was deliberate. It's possible to remove a language from the lexicon by giving it a bad reputation, or by using the word for an unrelated property. Using unconventional syntax, it makes perfect sense to call the sun a positive gravitational mass and the earth a negative gravitational mass. Whether or not a mass is positive or negative depends on the direction of motion relative to another mass. The sun has exergy and the earth has energy. This sort of thinking is consistent with Heaviside's 1800s theory of gravitational electromagnetism. Are synchronous movements responsible for gravity, while movements which are out of sync are responsible for electricity? To learn more about that perspective, you need to read more about the Barry phase, or just spend some time thinking about gravity in multiple languages that are each individually self-consistent, but which are inconsistent with one another. In some sense, I think that understanding flat Earth cosmology can help you with this, because from some perspectives, flat Earth cosmology is a self-consistent yet parallel language, which is inconsistent with the language everyone else uses. It requires you to bend objects in your mind in strange ways, which other people who speak more conventional languages do not have to do. It's a useful exercise to understand, and it makes us stupider to simply make fun of flat Earth cosmology. It is a valuable heuristic, a teaching tool to help people understand how coordinate systems work. So the important takeaway is that you really have to do your own thinking to understand all of this. It's not just a matter of memorizing something somebody said. And when you do this, you will see that Einstein's theory of general relativity drew inspiration from Heaviside's understanding of mass and electricity. But the Euclidean ideas Heaviside was using got kind of bastardized and mixed together in Einstein's mind with Minkowski's work, which was interesting in its own right, but neither of those theories were designed to be mixed together. This unfortunate mix-up completely undermined physics' conceptual basis, and it is up to you, the next generation, to unmix Einstein's confusion. And a lot of people have already figured this out. The challenge they have is agreeing on a common language, something that is taught in all classrooms. If you just introduce your own private language, you're not going to help matters. If you call it your theory of everything, you're not helping. You need to start speaking with others and consolidate your terminology. Now, for the kinematic pièce de résistance, I can't speak French, tying all of this together. Attraction occurs between currents moving in the same direction, and repulsion occurs between currents moving in opposite directions. And we call this attraction or repulsion magnetism when it is a current of charge, something of low density. And we call it gravity when it is a current of mass, something with high density. In order to build up the structure of the forces, I will start with the macroscopic effects of electricity and work down towards the microscopic. Magnetic attraction occurs between charges that are moving in the same direction. Magnetic repulsion occurs between charges moving in opposite directions. If you now imagine an individual particle as composed of spinning charge, you will be forced to conclude that electric repulsion occurs between particles spinning in the same direction. Electric attraction occurs between particles spinning in opposite directions. You really have to develop a mental animation of all of these things. If you can't create objects in your mind that move and spin around, and if you can't move your hands around to have a feeling in your body of these sorts of movements, you really shouldn't be a physicist, because you can sometimes describe these things mathematically without understanding the movements. But if you try to become a teacher with only that limited sort of understanding, you are going to confuse everyone, and you really shouldn't do that. So understanding the math only doesn't mean you understand it. You have to understand both the kinematics, the heuristics, and the mathematics. Otherwise, do not teach this stuff seriously. Students are suffering. I know, because I sat in classrooms like that. Okay, continuing. The currents around the particle's edges are going in opposite directions when they are spinning in the same direction, as in the spirals I've posted in the picture in my blog post. I'm sure you can criticize my attempt to teach this, but I feel like this is a part of the narrative that doesn't get written down in physics textbooks. It is something that teachers explain in classrooms, and there is the danger that if students didn't understand this, or the type of students who understood this got filtered out of the system, that these sorts of explanations will be lost, and they are valuable. The heuristic and kinematic explanations should not be lost in this time of technical transformation, when the only thing that really gets passed forward are the textbooks which don't give you as much of an intuitive feel. They just have the mathematics. You need both. So I'm trying to make a record of my memory of a classroom experience from the pre-internet age. In order to get the cause of charge itself, I now ask, how is an electron in an atom always spinning without losing any energy? And then I look at the modern concepts of non-luminiferous ether, zero-point energy, vacuum energy, virtual particles, or whatever you call the fluctuating energy density of space. This is a sort of list of keywords which can help you search for these topics, but they're all the same thing. And I will say that there is an incoherent vibration filling the vacuum, and it becomes coherent in the presence of matter, driving the currents and waves which keep the tornado-like spin of the electron in motion. The coherent energy density of this vibration can be thought of as the source of electrostatic force. Charge repels when density is high. Charge attracts when density is low. Now I will switch to gravity and build it up from the microscopic up to the macroscopic. Per gravito-electromagnetism, gravity is just like electricity and magnetism, but with a weaker coefficient, longer interaction distances, and the direction reverse. Thus, mass attracts when density is high, mass repels when density is low. You see, this is the opposite of the properties of charge. Now we add our knowledge about how spinning mass warps space. Rotational attraction occurs between masses that are spinning in the same direction. Rotational repulsion occurs between masses spinning in opposite directions. These forces can be observed between spinning wheels, and general relativity describes what they look like for interactions between massive stars. The effects become more dramatic on the galactic scale, where it is not unreasonable to use gravito-electromagnetism to conclude that gravito-magnetic repulsion occurs between masses moving in the same direction. Gravitomagnetic attraction occurs between masses that are moving in opposite directions. So when I use the term gravitomagnetic, I'm just trying to emphasize that gravity and magnetism are both properties described by moving mass. It's a sort of unification of the forces. This leaves us with dark energy and dark matter, popular science concepts. These are examples of gravito-magnetic repulsion and attraction. Many offer discouraging advice about the quantitative case for this sort of unification of the forces, but I investigated it independently, just reading what's available online, and I found this unification rather quantitatively promising. Even rough calculations yielded reasonable agreement. I have a couple of links to those calculations in my blog post, and I encourage you to look at them. In order to further connect gravity and electricity, there is statistical evidence that atomic and solar systems are composed of objects with a fixed ratio between the angular momentum and magnetic moment. This is another way to understand how to unify forces by using the concept of the magnetic monopole and a recursive definition of the forces. This sort of frequency comb is another good buzzword to learn. When you study this, you see that the big picture is present in the existing physics literature. What it lacks is a coherent language. Every subspecialty is using its own private language, and you have to learn all of them in order to translate between them and understand how all of the puzzle pieces fit together. It's very irritating that this is how physics education has been structured, and it came about in the aftermath of the world wars. And it makes one wonder if this was a deliberate effort to compartmentalize the languages of physics, to protect us from the power of physics. But I think if you go back in time and read physics from earlier times, you'll see that you can find the threads of unity and weave them back together. It takes an independent effort outside of the classroom because they will not teach this to you. You start physics thinking they're going to explain the big picture to you. They don't. They just give you the puzzle pieces. And it may be years after, maybe you quit your job, or you switch fields, or you're unemployed and you have all of this time, and then suddenly you can put the pieces together. But then you're left with no one to talk to about it. And so you see people on the internet trying to explain what they understand in their own private language, and they find that no one else speaks their language because there is no common language. And I'm trying to, by making this post, I hope I gave some assistance to the effort to form a more coherent language and dialogue about these things. Thank you for watching. This has been a long post, and please tune in for the next ones. They will be on topics similar to this one. Thanks.